Welcome to my channel. My name is Inayati and today I'm going to talk about automotive engine specifications. In an engine, we need a fluid as a fuel to be combusted and produce the torque from the force that is applied on the crankshaft, and this torque is going to be delivered to powertrain and eventually to the tires that are interface of the vehicle on the road for negotiation. Here I have listed the fuels that can be used in internal combustion engines, and they are gasoline, diesel, biodiesel, alcohol, CNG and LPG. From this list, gasoline or petrol in British is the fuel that is used more than others in automobiles and is the fuel type and powertrain type that I'm going to talk about in this video. With this assumption, we go to next characteristic, that is engine specifications. For a gasoline engine, there are many features and technical things to talk about, but there are specific features and technical things that are supposed to be demonstrated by all car manufacturers in car catalogs, and I have listed 4 of them for you here. And if you want to get familiar with all of these features and technical things, you can follow my videos and watch them in the future. These 4 features are number of cylinders and their layout, displacement, maximum torque and maximum power, and fuel consumption. First thing for an engine to be considered is number of cylinders and their layout. Because of technicalities, number of cylinders for an engine is mainly even, with exception of some models of 3 cylinders and a few cases of 5. Also, first choice for a car would be inline cylinder layout, but due to space considerations, V-type and recently W-type are also on the table for designers to choose. So as you can see, this feature is designer's challenge and not yours. But what is the point in knowing number of cylinders and their layout for your car's engine? I'll explain in the following. Next feature is displacement. Displacement is presented and expressed in liters and is defined as the aggregate volume of all pistons in cylinders that sweep during one revolution of crankshaft for a 4-stroke engine. Imagine a piston that is in its bottom dead center or lowest point of its travel. Now, crankshaft starts to rotate and piston moves up to the point that it starts to come down again. If you calculate this volume that this piston sweeps during this movement and multiply that into the number of cylinders, you have displacement of that engine, and sometimes this number or multiplied in 100 or 1000 is marked on the body of the cars, especially for the cars that have a model with 2 or more engines and displacement in the market. But this feature is also designer's concerns. But why these information are given in brochures or sometimes are marked on the body of the cars? Because these information are very important. Number of cylinders, the layout, displacement, and if the engine is turbo boosted or not boosted are the information that can give you a fairly true conception of the car's performance regarding power, torque, fuel consumption, and even engine sound and many other features that may be important for you as a customer. Okay, let's go to next feature of a gasoline engine, that is maximum power and maximum torque. If you refer to a car catalog, you can find almost in all of them a graph like this that represent the amount of power and torque in relation to engine rotational speed that is given in revolutions per minute or RPM. Sometimes these graphs are summarized into this format and are presented to customers. But to understand these graphs and numbers, first you need to know some definitions. Definition of work, torque, power, and energy. Imagine yourself. You have some energy in your body that is reserved in your blood and cells, and you know them as calories. Now, if you use this energy to move an object, you apply a force to that object, and the result in technical language is the work that you have done. Also, work is defined as the amount of energy transferred or converted. Now, if you use this energy to turn something, you apply a torque to that object. And now imagine that you are trying to turn a crankshaft. If the torque that you are applying to this crankshaft is big enough to overcome its initial resistance, the crankshaft starts to rotate with a certain speed. And from here, you need to use your power to keep this movement and rotation. So crankshaft resistance is drawing power from your body and is defined as the rate of work or energy transferring or converting time, and is defined as work over time. Also, you can calculate energy that you use to turn that crankshaft during a period of time by multiplying the magnitude of power that you use into time duration. Now let's go to units. If we have force in Newton and distance and length of the lever in meters, so torque is in Newton meter and also work is in Newton meter. But torque is a vector quantity and work is a scalar quantity. A vector quantity has direction and magnitude, but a scalar quantity only has magnitude, and in this case we have another unit for work, that is joule, and 1 joule is 1 Newton meter. And as I said, power is work over time, so joule per second, and 1 joule per second is defined as 1 watt. And also we have another unit for power and is horsepower, and 1 horsepower is almost equal to 746 watt. And energy, according to definition, is power multiplied in time, so joule per second multiplied in second equals to joule. And also we have another unit for energy that all of you know, and is calorie, and 1 calorie is almost about 4 joules. Okay, now let's study a graph. To achieve a high torque, you need to use a lot of juice and a lot of air to produce a strong combustion. But you cannot produce maximum torque in low engine speeds, because in low engine speeds, engine tends to stall, but in a certain speed you can take engine under full load. But after that engine speed, the torque is going to come down because of some technicalities and air supply limitations. In this case, engineers try to make this line as flat as possible at maximum by playing with features like boost regulation, valve timing, fuel injection duration, and ignition strategies. Now we go to power. Power in theory is in direct relation to torque and RPM. So when torque is increasing, power is rising too. But when torque is coming down, power is not following, because as I said, power is in direct relation to RPM too, and RPM is increasing up to the point that inefficiency and reduction of torque is a bigger player and power is coming down too. To increase these numbers, you can use turbochargers and superchargers, and an engine with boosted air supply system and fuel consumption as a compromise has a better performance under load. This boost system can be designed by engine designer or by aftermarket suppliers, and they come in a package called boost control system. This boost control system is expensive relatively and takes its toll on engine's life, and also installing them by aftermarket shops needs ECU reprogramming that may affect emissions. In general, buying a car with a boosted engine imposes you with some extra bucks and some maintenance concerns that you do not want to face, but in some applications it is inevitable, and also it is very exciting to drive and speed up a very strong boosted engine car. Okay, fuel consumption. Fuel consumption is expressed in two ways: liters per 100 kilometers in a SI system and miles per gallon for UK and US system. Maybe I can say that this parameter is the most important thing in lower and middle class cars, and all parties have concerns about that: producer, consumer, and government. And many features of a car can affect this parameter, like efficiency of powertrain, aerodynamic drag, weight of the car, rolling resistance and inflation pressure of tires, efficiency of suspension system, and even accessories like air conditioning system, and even your driving habits can affect fuel consumption. But most important thing in this field is efficiency of power plant or engine, as a nice and modern gasoline engine has the thermal efficiency of about 35%, and a demand for a better and more efficient one always exists. And if I want to wrap it up nicely, I can say that there are 2 points regarding fuel consumption. First, you can compare the fuel consumption of your target car with its rivals if this parameter is important for you, and also the rates and numbers that are presented by car manufacturers are the rates and numbers that are obtained in laboratory conditions under certain loads of a dynamometer, and you may do not meet these rates and numbers even in highway driving conditions. I hope that this video was useful and informative for you and worth the precious time that you spent for watching that. Please subscribe to my channel if you like and press the bell icon to be notified if I have a new video on my channel. Bye.